Today we're going to start Chapter 9. Chapter 9 is on sequences and series. And a sequence is just a set of numbers written in a given order. Hopefully you can see that. A set of numbers written in a given order. You studied sequences last year in Algebra 2. Each number in a sequence is called a term. And terms are, the notation of a term is the lowercase a. The lowercase a, and then you have a subscript of n. So you can either say a sub n, or you can say the nth term. So a sub n is equal to the nth term. So the first term is a sub 1, the second term is a sub 2. So for example, if you have the a sequence 1, 2, 4, 8, 16, 32, the first term is 1, the second term is 2, the third term is 4, the fourth term is 8, etc. So terms are written with the a subscript 1. Finite sequences end. Infinite sequences never end. Infinite sequences have ... at the end. I shouldn't have put ... after the 8 because that has another meaning now within the chapter of sequences. So I can just put, etc. etc. All right, so you can define a sequence with a specific formula sometimes. Sequences are defined with an explicit formula. For example, you might see a formula like this. A sub n, or the nth term, is 3n minus 2. That's a really simple one. So if you're asked for the 100th term, you just let n equal 100. So the 100th term is equal to 3 times 100 minus 2. 300 minus 2, I think, is 298. So the 100th term is 298. So whatever n is in the explicit formula, that's the term number. The fifth term would be 15 minus 2. The 1000th term is 3000 minus 2. Whatever n is the term number. So that's when sequences are defined with an explicit formula. Sometimes sequences are not defined with an explicit formula. Sometimes they'll have a recursive formula. So I'll say sometimes it's this, but other times sequences are defined with a recursive formula. All right, with an explicit formula, you can determine or you can calculate any term you want by just substituting an n with whatever term number you have. But if you have a recursive formula, you can't determine what the 100th term is unless you've determined what the 99th term is, because a recursive formula depends on the value of the term before it. So any term in a recursive sequence depends on the previous, see that, previous term's value. Okay, that's recursive formula, and I'll give you a couple of examples of recursive formula. You must be given the value of the first term. You must be given the first term value, which is a sub 1. So they have to tell you what a sub 1 is equal to. Then you must be given a formula for the next term. You must be given a formula, some kind of a formula, to calculate the next term. All right? The next term is usually called a sub n plus 1. All right, so whenever you see the subscript of n plus 1, you know you have a recursive formula because it's telling you the next term is equal to some function of the previous term. All right, so that's just written in function notation. You're not going to see it explicitly written like this. You might see, well, I'll show you some examples of some recursive sequences. But sometimes you're going to see the next term called a sub n. Sometimes the next term is called a sub n, which means the term before it is a sub n minus 1. All right. So in a recursive sequence where they call the next term an, that means the next term, it is some function of the previous term, so you'll have an n minus 1 here. So they're really similar. It's just the two different ways of writing the same thing. They could put an n plus 1 here, means the next term depends on that previous term. Or they could say the next term is dependent on that previous term. It's just two different ways of writing the same thing. So I just hope you're not confused by that. Hopefully I'll give you a couple of examples of it written both ways. All right. So let's do some examples of, or an example of a recursive sequence. Okay, you have to be given the first term's value. So I have to tell you what A1 is. Let's say A1 is 20, or the first term is 20. You must be given this, or else you don't know where to start. Okay, then I'm going to tell you the next term is equal to that previous term plus 5. That's just an example. So this is the function of the previous term. The next term is you take the previous term and just add 5 to it. Okay, this is called the recursive definition. You must be given this, or else you can't determine what the next term is. So you must have that also. You need two things for recursive sequence. You need a first term, you need a definition. So if I want to write the first 5 terms, I say, well, the first term is 20 because they already told me that. The second term is you take the first term and add 5 to it. So the second term is 25. The third term is you're going to take the second term and add 5 to it. So the third term is 30. The fourth term, you're going to take the third term and add 5 to it. So you got 35. And the fifth term, you're going to take that previous term, which is 35, and add 5 to it, and you got 40. So the first 5 terms are 20, 25, 30, 35, and 40. This could be written with an explicit formula, but I've given it to you as a recursive formula. All right, so let's do another example, and I'll have it written the other way. So here's your second example of a recursive sequence. Let's say the first term is equal to 2, and then let's say the nth term, when n equals 2, is equal to 2 times the previous term. Oh, you know what? Let's call this a sub 0. We would have to do that if we want to get the first term when n equals 1. So what we're going to do is write the first 5 terms of this sequence. So the first term, they're just calling it a sub 0. So the first term is 2. The second term is 2 times the previous term, which is 4. The third term is 2 times the previous term. Well, the previous term is 4. The fourth term is 2 times the previous term, which is 8. And the fifth term is 2 times the previous term, 16, which is 32. So each one of these terms depended on the previous term, because you're going to multiply each one by 2. All right, so that's a recursive sequence. Now the two specific type of sequences that you can talk about with explicit formulas over here, this first kind, you've got explicit versus recursive, so I'm going to show you a couple of explicit types of formulas. Of sequences, rather. Two types of sequences having explicit formulas. The first type is called an arithmetic. Hopefully you remember this from Algebra 2. And the second type is called geometric. In an arithmetic sequence, the difference between any two terms is always the same, or between two subsequent terms. Difference between consecutive terms are always equal. So they go up or down by a certain amount, of the same amount every time. In a geometric sequence, the ratio between consecutive terms is always equal. And the difference is called D, and the ratio is called R. So these are two totally different types of sequences, arithmetic and geometric. So for example, if you have this sequence 4, 2, 0, -2, -4, and we'll continue that infinitely, is this arithmetic or geometric? Well, to determine whether it's arithmetic or geometric, you just subtract two terms. 2 minus 4 is the same thing as 0 minus 2, is the same thing as -2 minus 0, is the same thing as -4 minus 2. So that has a common difference, and that common difference is -2. In other words, you just keep going down by 2's. So that's arithmetic. Okay, subtract any two consecutive terms and you always get the same thing. And an example of a geometric sequence, maybe you'll have something like this: 81, 27, 9, 3, ... Now, if you subtract any two consecutive terms, you don't get the same thing. But if you divide them, 27 divided by 81, 9 divided by 27, 3 divided by 9, this common ratio is you take any later term, divide it by the previous term, so 27 over 81, and you always get 1/3. That is the common ratio. And to get the difference, you can just calculate that if you want to. It's pretty easy. I think you probably remember it from last year, but all you have to do is take a later term and subtract the previous term from it, and that's what D is. The second minus the first, or the fourth minus the third, or the 10th minus the 9th. Same thing here. So those are two different types having explicit formulas. You could write formulas for each one of these, and hopefully last year in Algebra 2 you learned how to write the formulas for them, and let's go over that. So how to write a formula for an arithmetic sequence, like the one I gave you. What did I start with? I started with a 4, I think. Yep. Like 4, 2, 0, -2, -4, ... Okay, so an arithmetic sequence. The nth term of an arithmetic sequence is always equal to the first term plus whatever the difference is between those two terms times n minus 1. This is hopefully a formula that you learned last year and you have to memorize. You had to memorize it last year. I'm going to continue to ask you to memorize it this year. So you're going to memorize this. So if I wanted to write an explicit formula for this arithmetic sequence, this is our example. Our example says any term in this sequence is equal to the first term, which is 4, plus the difference between these two consecutive terms is -2 times n minus 1. Now n is the variable in this, always. All right, so all you have to do is distribute the -2 and combine like terms. So 4 minus 2n plus 2, which is equal to, we can write it in y equals mx plus b format when n is like the letter x. So that's -2n plus 6. So there is your explicit formula for the nth term. So the 100th term for this particular sequence that I gave you up here is written A100. That is equal to, all you do is substitute 100 in for n, so you have -2 times 100 plus 6. Let's see, -200 plus 6 is -194. Is that right? I hope so. If I make any mistakes, you notify me. All right. So there's another formula that you also have to memorize for the geometric sequence. So here's our second little thing, how to write, and this is just a review of Algebra 2, I hope you remember it, how to write a formula for a geometric sequence, like The one that I gave you, I think I started at 81, 81, 27, 9, 3, dot, dot, dot. Okay. The nth term of any geometric sequence is equal to the first term times whatever that common ratio is, raised to the power of n minus 1. Okay, this is the second thing that you have to memorize. Last year you had to. This year you're going to have to continue to memorize it. All right? So for our little example that I gave you up here, if I want to know the nth term of this particular sequence, I start with the first term, which is 81. The common ratio, 27 over 81, is equal to 1/3 times n minus 1. Now, I wouldn't want to get the 100th term because 1/3 raised to the 99th power is just so tiny the calculator probably couldn't even handle it. So let's say I want to get the 1, 2, 3, 4, 5. Let's say I want to get the 6th term. So the 6th term is equal to a with the little subscript of 6, which is 81 times 1/3 to the 5th power, which is 81 times, what's 3 to the 5th? I don't know, I'll figure that out. Come on, turn on calculator. 243. So 81 times 1 over 243, which is 81 over 243, and I think that can probably be reduced to 1/3. So that makes sense because the next term here would be a 1 if you keep dividing by 3. So 81 divided by 3 is 27, divided by 3 is 9, divided by 3 is 3, divided by 3 is 1, and then that 6th term would be 1 divided by 3. So those are two specific formulas that you have to memorize for this chapter. And there are going to be a couple more of them. But I think that'll probably be it for today.